Mathematics and science makes use of symbols. A symbol is nothing more than a character that has a significant meaning. Following is nothing but a written symbol. However, we have come to know that this symbol represents a particular quantity, specifically the quantity 5. When we look at numbers, the actual number we see on a piece of paper really is nothing more than a symbol representing a quantity we wish to describe. In science, we use symbols to represent numbers that can vary. For instance, we can say that x is equal to 3 and y is equal to 4. Then x is a symbol representing a specific quantity, as is y. Now we can write relationships between these two symbols, such as y minus x equals 1, which, of course, since y is equal to 4 and x is equal to 3, then that's the exact same thing as 4 minus 3 equals 1. This mathematical relationship between x and y is called an equation. But if we eliminate the required values for x and y, then our equation y minus x equals 1 can represent any variety of numbers, such as 5 minus 4 equals 1, 3 minus 2 equals 1, and 100 minus 99 equals 1. X and y are now what we call variables, since the values of x and y can vary and still satisfy this equation. We can tell so much from one simple equation. One thing we see a lot in equations is how one variable responds to another's behavior. Let's take one of the most famous equations in all of the physical sciences, F equals ma. This equation states that a force F, that is a push or a pull, is applied to a mass m, which accelerates with a value a. Now assume that the size of the object or the mass does not change. Then what will happen if the force increases? The only way to keep this equation equal is if the acceleration also increases. Now I can show this here by inserting some values in place of each variable. So the force is 6, the mass is 2, and acceleration is 3. Now if I increase the force, then in order for this equation to stay equal, the acceleration also has to change in order to keep the equation balanced. Such a relationship is said to be directly proportional. That is, as one variable increases, the other also increases. Now let's take the same equation and see what happens to the acceleration if the mass increases and the force remains the same. If the mass increases, then the only way to keep this equation equal is for the acceleration to decrease. Again, I can show this using some values for each variable. Force is 24, mass is 6, acceleration is 4. Now if I increase the mass, notice that the only way to keep the force the same is to decrease the acceleration. This type of relationship is said to be inversely proportional. That is, as one variable increases, the other decreases. There are other ways to compare two numbers. One comparison is called a ratio. A ratio is basically a relationship of two numbers when one value is divided by the other. These two numbers can represent anything, including properties of objects in nature. For example, let's take a box. Let's give this box a mass of 20 grams and a volume of 2 milliliters. A simple ratio would be a comparison of the mass to the volume. In this case, the ratio would be 20 grams divided by 2 milliliters, which simplifies to 10 grams per milliliter. Now let's take a second box with the same mass, but now double the size. When we look at the exact same ratio between mass and volume, we find that even though the mass has not changed, this ratio has. Now there are 20 grams in 4 milliliters, which reduces to simply 5 grams per milliliter. This particular ratio is an important property of matter. We commonly call it density, which is symbolized using the Greek letter rho, which is kind of this round P looking thing. It's a Greek letter rho, R-H-O. So density is defined to be the mass per volume. Ratios and proportionality are only two ways of comparing numbers. Many of the principles taught in algebra are very handy to compare properties in science. Throughout the course, we'll see some of these algebra methods pop up again.